Hello my friends and welcome back to the You Can Do TV channel. See what happens when a vintage engine is awakened after years of silence. As the old machine is started, the entire engine mass begins to jolt and shake violently, as if resisting the stillness of decades past. The flywheel turns unevenly, the frame rocking hard enough that two people must stand close to restrain and control it. Thick white smoke pours from the exhaust, carrying the sharp scent of oil and partially burned vapor. The rough, unstable sound reveals a machine slowly rediscovering the rhythm of its mechanical golden age. The Rolls-Royce Centurion V12, a massive 27-liter engine, roars to life as a direct descendant of the legendary Merlin. Originally adapted for armored vehicles, this power plant shares its DNA with the engines that propelled the P-51 Mustang and the Supermarine Spitfire across wartime skies. In this configuration, the supercharger has been removed, prioritizing low-end torque and durability over high-altitude performance. Even so, the unmistakable V12 cadence remains smooth, mechanical, and commanding. Each startup echoes the precision of British engineering, where aircraft technology was transformed into unstoppable ground power. The Mercedes-Benz is a V12 bi-turbo industrial diesel engine, delivering up to around 1,200 horsepower. With a displacement of approximately 22 liters, it provides exceptional low-speed torque, high durability, and reliable performance for heavy industrial, marine, and power generation applications. Built for relentless oilfield duty, this antique 50-horsepower Superior engine showcases the brute simplicity of early industrial power. A massive single-cylinder design, displacing two 463 cubic inches, it converts slow, deliberate combustion into steady torque rather than speed. Running on natural gas, the engine delivers a deep, rhythmic exhaust beat that defined remote oil production sites. Heavy cast iron construction, oversized bearings, and minimal moving parts allowed continuous operation in harsh conditions. Still running today, this engine stands as a living demonstration of early oilfield engineering built for endurance, reliability, and sheer mechanical authority. Witness history in motion at Victoria Village Bliss Hill Iron Bridge, where a working replica of the first steam locomotive designed by Richard Trevithick in 1804 is still in operation. Built decades before Stephenson's rocket, it proved groundbreaking yet impractical, its weight and reliability limiting adoption, while Trevithick turned his focus toward powerful steam engines for mining. Deep within the fortified galleries of Artilleriewerk Maglech, Sulzer emergency diesel engines were engineered to guarantee absolute operational reliability under all conditions. These heavy-duty generators were designed for immediate startup, delivering stable electrical power to ventilation systems, communications, lighting, and weapons controls in the event of grid failure. Fuel storage, cooling, and exhaust systems were fully integrated into the underground structure, ensuring autonomous operation during prolonged isolation. More than backup machines, these engines formed the mechanical heart of the fortress, embodying Swiss engineering principles of redundancy, durability, and uncompromising reliability. The 2NVD21 is a classic stationary diesel engine representing post-war industrial reliability. Built in 1958, this two-cylinder four-stroke diesel features a normal stroke of 21 centimeters, delivering steady torque for continuous operation. Designed for fixed installations, the engine was commonly used for power generation, pumps, and industrial machinery, where durability mattered more than speed. Its slow revving character, heavy cast iron construction, and mechanical fuel injection reflect an era when engines were engineered for decades of service. The rhythmic firing of its twin cylinders showcases robust German diesel engineering at its most enduring. Introduced around 1913, the Bate steel mule stands out as one of the most unconventional tractors ever built. Power came from a small gasoline engine, driving the rear track through simple gearing, delivering steady, low-speed torque suited to farmers accustomed to horse-drawn equipment and early mechanization. The Deutz 328 stationary engine represents a defining chapter in early industrial diesel engineering. Built between 1929 and 1936, this single-cylinder powerhouse delivers 18 horsepower at just 540 revolutions per minute, relying on massive displacement rather than speed. With a bore of 280 millimeters and a 170 millimeter stroke, every combustion cycle is slow, deliberate, and deeply mechanical. Starting is a ritual in itself. Glow paper ignites the pre-chamber, assisted by an auxiliary injection nozzle before the crank handle brings the engine to life. The pre-chamber combustion system ensures stable ignition and smooth running, even at low rotational speeds. Once running, the 328 settles into a steady, authoritative rhythm, perfectly suited for generators, pumps, and workshop machinery. Heavy cast iron construction, minimal complexity, and exceptional durability define its character. This engine was built to work relentlessly, embodying Deutz's philosophy of precision, longevity, and mechanical honesty. The 1911 Fiat S76, known as the Beast of Turin, embodied raw ambition at the dawn of high-speed motoring. Created solely to dominate land speed records, this extraordinary machine was built around a colossal 28.3-liter four-cylinder engine, delivering roughly 290 horsepower, an almost unimaginable output for its era. Each cylinder dwarfed those of many modern cars, forcing a long, narrow chassis with exposed mechanics and an imposing bonnet. Engineered to outmuscle rivals like the Blitz-Benz, the S-76 thundered past 200 kilometers per hour on venues such as Brooklands. Though denied an official record, it remains a brutal, unforgettable symbol of early automotive daring. At the 2018 Billsport Performance and Custom Motor Show in Elmia, Victor Johnson's radical creation roared to life for its first test start. Built on an extended Volvo PV 544 chassis, the project is dominated by a massive 38.8-liter Transmash V12, pure mechanical excess on display. Installed within the stone walls of Oscar Fredriksborg Fortress near Stockholm, the 1910 Polar Diesel T3K represents an early milestone in stationary power generation. Built as a robust single-cylinder diesel, this engine was designed for continuous, dependable operation rather than speed. After a careful group-led restoration, the T3K is once again fully functional, driving a generator capable of producing 110-volt direct current, exactly as it did in the early 20th century. Heavy cast-iron construction, slow rotational speed, and precise fuel injection reflect the engineering priorities of the era: efficiency, durability, and mechanical simplicity. Today, the Polar Diesel T3K stands as a living demonstration of early diesel technology and its role in powering critical infrastructure. Halloween brings a playful twist to the Romney, Hythe, and DYM Church Railway at Dungeness, where steam and spectacle share the spotlight. As the season draws to a close, Hurricane was a powerful, small Pacific-type steam locomotive with a 4.6 wheel configuration. And the Winston Churchill, a 4.60 locomotive, emphasized traction and stability, with outboard cylinders and a robust steel frame optimized for double-drawing operation. Leading the way is a series of exhilarating double races. These special races, combined with member-exclusive trains, transform the railway into a moving festival celebrating heritage and performance. Driven entirely by flowing water, the Opgang Saga frame sawmill converts hydraulic energy into precise vertical cutting. A wooden water wheel powers gears and a sash saw, rhythmically slicing logs into boards. This centuries-old mechanical system remains fully functional, efficient, and essential for authentic timber production. Steel, steam, and motion come together as a 20-horsepower Waterloo steam engine is put to work in classic threshing duty at the 2016 Huron Pioneer Threshers and Hobby Association event in Blythe, Ontario. The engine's boiler builds pressure methodically, sending power through a massive flywheel and flat belt to a George White No. 6 threshing machine. With every steady revolution, the belt transmits torque to the separator's drum, shakers, and blowers, bringing the entire system to life. Inside the threshing machine, grain is separated through a precise sequence of beating, screening, and airflow, all driven by mechanical timing rather than electronics. The Waterloo's slow, deliberate exhaust and rhythmic chuff set the pace, demonstrating how early steam power delivered reliable, continuous energy for agricultural production. Together, engine and separator showcase a fully integrated mechanical process that once defined large-scale farming efficiency. Developed in 1909, the Jastrom Flugzeug motor represents the experimental era of early aviation engines, when reliability and power-to-weight ratio were still being defined. This compact aircraft engine features a lightweight metal construction, exposed valve gear, and a direct mechanical layout optimized for low-altitude flight. The Jastrom engine illustrates how early engineers balanced simplicity, weight reduction, and durability at the dawn of powered flight. At the Kempton Steam Museum, the Sir William Prescott steam engine awakens once again in its 2023 startup. Built in the 1920s to secure London's water supply, this colossal triple-expansion steam engine represents the absolute peak of steam-era engineering. As boilers raise pressure and valves come alive, steam is admitted in carefully controlled stages, driving the high, intermediate, and low-pressure cylinders in perfect sequence. Massive connecting rods begin their slow, deliberate motion, turning flywheels that weigh several tons with remarkable smoothness. Every sound, escaping steam, oil-fed bearings, and the rhythmic pulse of pistons, reflects an age when reliability and mechanical precision were paramount. Designed to run continuously for decades, the Sir William Prescott engine converts thermal energy into rotational power with exceptional efficiency for its time. This startup is not simply a demonstration, but a living lesson in industrial-scale steam power, preserving a masterpiece that once quietly kept a great city running. The Marine 7-cylinder Radial engine delivers smooth, continuous power through a compact, air-cooled layout. Designed for durability and balance, its evenly spaced cylinders ensure reliable torque, efficient combustion, and a distinctive rhythmic operation ideal for marine and industrial applications. At the Oklahoma Steam Threshing and Gas Engine Association's 50th annual show, a 40-horsepower Case steam traction engine takes center stage in the classic incline demonstration. Weighing nearly 18,000 pounds and driven by a single-cylinder steam engine, this machine showcases the raw torque that once transformed American agriculture. Steam pressure is carefully balanced as the engine climbs the ramp, then holds position without brakes, suspended solely by controlled steam on either side of the piston. Unlike internal combustion engines, it delivers 2 power strokes per revolution, explaining its immense low-speed pulling force. This demonstration echoes Case's early 1900s hill-climbing feats, proving why steam power earned its legendary reputation. Fed from above, the Overshot water wheel turns by the sheer weight of falling water, not by forceful flow. As each bucket fills, gravity pulls the wheel forward in a slow, deliberate rotation. This elegant mechanism converts natural elevation into smooth, reliable motion, showcasing how early engineers mastered energy using nothing more than water, wood, and iron. Step inside a cathedral of power, where steel, steam, and precision once kept the city alive. This epic drone tour glides through Kempton Steam Museum, revealing the world's largest working triple-expansion steam engine in breathtaking detail. From soaring fly-throughs of the Grade II listed engine house to closed passes over massive cylinders, connecting rods, and towering flywheels, the footage captures the true scale of early 20th century engineering. Built in the 1920s, this steam pumping station showcases how thermal energy was transformed into smooth, relentless mechanical motion. Every rotating shaft and polished valve tells a story of efficiency, endurance, and industrial ambition, an awe-inspiring reminder of an era when steam ruled the machinery of the modern world. Deep within the hull of the paddle steamer Waverly, the engine room comes alive as the ship eases away from Tyne-Bruich Pier. Twin triple-expansion steam engines, dating from the mid-20th century, drive the massive paddle wheels through polished crankshafts and valve gear. Steam pressure is carefully balanced as pistons rise and fall in perfect sequence. Every movement is visible, audible, and mechanical, offering a rare, working example of classic British marine steam engineering in motion. At Tankullamotorns DAG 2014 in Lysekil, the steady rhythm of a classic Fairbanks Morse diesel engine brings early industrial power back to life. Built around a robust single horizontal cylinder, the engine relies on massive flywheels to smooth each combustion pulse, delivering slow, deliberate torque rather than speed. Through a traditional belt drive transmission, this stored rotational energy is transferred directly to a working wood saw, demonstrating how engines like this once formed the backbone of small-scale industries. Alongside it stands the Scandia 120 BV, rated at 23 horsepower, a hot bulb diesel design known for mechanical simplicity and fuel flexibility. With no electronics and minimal controls, every movement is visible. The flywheel inertia. More than a static display, this setup shows these engines exactly as intended. Working machines engineered for durability, efficiency, and continuous operation in an era when reliability mattered more than refinement. The Searson sawmill is defined by its machinery, robust, purposeful, and built to work without compromise. At the core of the operation, a powerful prime mover delivered steady rotational energy to an extensive line shaft system running the length of the mill. From these spinning shafts, wide leather belts drop down to each machine, driving circular saws, edgers, and planers in synchronized motion. The main saw dominated the floor, its heavy cast iron frame designed to absorb vibration as large logs were broken down with relentless accuracy. Carriage mechanisms advanced timber into the blade with controlled, mechanical precision, while feed rollers and guides kept each cut true. Secondary machines refined the output, trimming edges and surfacing boards to uniform dimensions. Every component was engineered for durability and serviceability. Exposed gears, bearings, and pulleys allowed constant inspection, lubrication, and adjustment. Operators relied on sound and motion to judge load and efficiency, making the mill a living mechanical system rather than an automated process. At Searson, power transmission, cutting technology, and mechanical coordination defined productivity, showcasing an era when industrial performance depended entirely on well-designed machines and skilled hands. Union Pacific Big Boy number 4014 commands attention wherever it runs. Its 4.884 articulation and 6 300 horsepower output turning heads trackside. As the world's largest operating steam locomotive, its thunderous exhaust, massive drivers, and sheer presence create instant connections with crowds across every community it visits. Built in 1935, the Deutz 322 stands as a testament to early German industrial engine design. After decades of service and careful preservation, this historic engine was started again in 2010, firing immediately after a long winter shutdown, a clear sign of its mechanical integrity. The single-cylinder diesel delivers its power with a steady, deliberate rhythm, characteristic of Deutz's slow-running work engines. During the winter period, the transport wagon received new wooden cladding, enhancing both protection and period authenticity, while a dedicated toolbox was added for operational readiness. More than a restoration, this first start highlighted the enduring reliability and craftsmanship that defined Deutz engineering in the pre-war era. Under the Elmia 2018 nightlights, mechanical violence takes center stage. An orange Volvo 242 T5 rolls into position, its engine sharpened for one purpose only. Throttle opens, revs climb, and the rear tires surrender instantly. Smoke floods the stage, illuminated by spotlights cutting through the darkness. Torque overwhelms rubber. Heat builds in seconds, and then impact one tire detonates with a sharp, unmistakable blast. There was a tire blowout sound. This was classic performance engineering pushed past restraint. Fuel, air, ignition, and courage aligned for a brief, violent display of automotive muscle. A Bentley fitted with the legendary Rolls-Royce Merlin V12 comes alive with unmistakable force. This 27-liter liquid-cooled aviation engine, originally developed for World War II fighters, features a 60-degree V12 layout and immense torque. Each rise in revs echoes wartime engineering, sheer displacement, mechanical precision, and raw power translated from the sky to the road. Built in June 1943, this Rolls-Royce Merlin Mk22 was originally destined for wartime service, most likely powering a Lancaster bomber. After its operational life, the engine was repurposed at a test facility, where it was used to generate controlled airflow rather than flight. Decades later, it underwent a careful 7.5-year restoration and was mounted on a purpose-built trailer. The startup sequence reveals the precision of classic aviation engineering, while the deep, thunderous roar and powerful blast of air remind audiences why the 27-liter V12 Merlin became one of the most iconic aircraft engines of the Second World War. The Erie Steam Shovel was a workhorse of early 20th century construction, built by the Erie Steam Shovel Company of Erie, Pennsylvania, which later became part of Bucyrus Erie, a global leader in excavation machinery. These massive cable-operated shovels use steam power to dig and load earth long before diesel hydraulics took over, revolutionizing quarrying and large-scale earth moving. A few rare survivors still exist today, testament to the bold engineering that reshaped landscapes long before modern excavators arrived. Fresh from an extensive rebuild, 5-inch gauge SAR Lolly No. 102 returns to steam for its long-awaited first run at the Morley track of the Derby Society of Model and Experimental Engineers. The project included a completely new boiler, restoring the locomotive's heart and ensuring safe, reliable operation. On the 6th of September 2015, No. 102 eased onto the rails, its motion smooth and confident as steam pressure built. This successful trial marked the culmination of countless workshop hours and careful craftsmanship, bringing a classic South Australian Railways Lolly locomotive back to life in miniature form. The Macacia corn shelling setup is a mechanical system designed to efficiently remove kernels from corn cobs. Powered by an engine or motor, corn ears are fed into a rotating drum or set of rollers that strip kernels cleanly while minimizing damage. The separated grain is collected for further processing or storage, while cobs are discharged as waste. Step inside the engine room of Cap San Diego and discover the technical heart of one of the world's last operational general cargo ships. The guided Technique Fart reveals massive manned diesel engines, reduction gears, generators, pumps, and control systems that once powered transatlantic voyages. Every valve, gauge, and shaft reflects robust marine engineering, designed for reliability, redundancy, and continuous operation at sea. Before gasoline ruled the road, a quiet rival moved on clouds of pressure and heat. The Sentinel S4 steam car captures that forgotten moment in engineering history where fire, water, and steel worked in perfect balance. At its core is a compact, high-efficiency steam boiler that generates pressurized vapor to drive the engine directly, delivering instant torque without clutches or complex gearboxes. Power builds smoothly as steam flows into the cylinders, producing strong, vibration-free motion that feels effortless yet commanding. Speed is controlled not by revs, but by precise regulation of steam pressure, transforming thermal energy into mechanical force with elegant simplicity. Drawing on Sentinel's heavy industrial steam expertise, the S4 combines durability with refinement, proving that steam propulsion was not a curiosity, but a serious alternative. High in the Italian Alps, a 100-year-old steam train returns to life along the Valsugana line, its exhaust echoing off mountain walls. Steel wheels bite into the rails as boiler pressure builds, driving pistons that once powered a nation. Every mile blends engineering endurance with Alpine scenery, where steam still rules the climb. Built in the early 20th century, the 15 HP Foos hit-and-miss engine represents classic American stationary engine design, widely used for driving pumps, mills, and farm machinery. It features a large, single-cylinder, low operating speed, and a hit-and-miss governor that controls fuel intake under varying loads. Known for heavy castings, robust bearings, and exceptional durability, Foos engines were designed to run for decades with minimal maintenance. This restored example preserves those original characteristics, allowing the engine to operate exactly as it did when first delivered from the factory over a century ago. Starting a national gas engine is a ritual that reveals how early internal combustion machinery truly worked. This single-cylinder engine runs on mains gas with spark plug ignition and relies entirely on compressed air. There is no starter motor to help. Cooling water is opened first, followed by releasing compression so the flywheels can be positioned just past top dead center by hand. The governor is engaged, gas supply opened, and the stop switch reset. With ignition retarded and compression restored, short, precisely timed bursts of compressed air bring the engine to life. Once running, ignition is advanced for smooth, steady operation. At first glance, the steam bike looks like a rough garage experiment, but its engineering tells a far more ambitious story. Built on a modified 1973 Yamaha dirt bike frame, this custom machine runs entirely on steam and can reach speeds of around 25 miles per hour. An old-school steam engine, heated by propane, provides the power, while water replaces fuel in the traditional sense. Constructed from repurposed materials and basic hardware, the bike was completed in just 4 weeks, proving how hands-on engineering can turn curiosity into working machinery. Have you ever wondered what the Titanic's engines actually looked like and how they moved such a colossal ship through the Atlantic? This detailed steam engine model represents the Titanic's port-side main engine, faithfully capturing the scale and complexity of early 20th century marine engineering. The original liner was powered by two 4-cylinder triple-expansion steam engines, each driving an outer propeller, with a low-pressure turbine turning the center shaft. In this model, pistons, valve gears, and connecting rods work in sequence, showing how steam was expanded step by step to extract maximum power. Every moving component reflects the engineering priorities of the era: reliability, smooth torque delivery, and efficiency for long ocean crossings. More than a static display, this model reveals the mechanical heart that once drove the world's most famous ocean liner. Departing Customs House Quay in Greenock, Waverley sets off under steam once more. Built in Glasgow in 1946, it remains the world's last operational paddle steamer. Once serving the Clyde, Waverley now carries passengers along Britain's coast, honored with a 2011 Engineering Heritage Award. On the dynamometer, the Case 150 horsepower steam engine is pushed to its limits. As the load climbs near 900 pounds, the massive flywheel steadies at around 190 revolutions per minute, delivering over 160 horsepower and immense torque, pure steam-era muscle, measured under real strain. During the Labor Day weekend, a Minneapolis steam traction engine demonstrates its working strength by pulling 8 plow bottoms across the field. Boiler pressure, massive flywheels, and slow, relentless torque combine to turn soil with authority, showcasing classic American steam-powered agriculture in full operation. At the heart of the Ruislip-Lido Railway Steam Gala, the Locomotive Mad Bess truly steals the show. A compact but powerful steam engine, Mad Bess embodies the elegance and simplicity of traditional steam traction. Coal and water are transformed into relentless rhythmic power, as steam pressure builds in her boiler, feeding the cylinders that drive polished rods and spinning wheels with measured authority. Though modest in scale compared to mainline giants, her character is unmistakable. Every exhaust beat, valve motion, and wheel rotation a lesson in mechanical precision and heritage engineering. As she hauls passengers around the scenic loop, Mad Bess not only recalls an earlier era of railroading, but shines as a working testament to the enduring appeal of steam on narrow-gauge rails. Built in 1934, this 132 bhp Ruston Hornsby oil engine represents classic British heavy engineering at its peak. Fully restored at the Phoenix Lake Goldsmith in Victoria, Australia, the engine showcases slow-speed reliability, massive cast-iron construction, and the enduring durability that made Ruston Hornsby engines indispensable in mines, mills, and remote industrial sites. Before the first wheel turns, the air already feels different. At the Finnish Railway Museum, a living chapter of steam-era engineering comes back to life as a classic 440 locomotive rolls onto the track. The run begins with a precise ritual. Propane burners are lit, heat builds steadily in the firebox, and the tender is filled to support the journey ahead. Steam pressure rises, valves respond, and the locomotive awakens with a familiar, purposeful rhythm. As pressure stabilizes, passengers step aboard, settling into a journey powered by heat, water, and steel. With a gentle exhaust beat, the locomotive gathers motion, wheels turning smoothly along the rails while steam works through cylinders polished by decades of service. Each lap is a living demonstration of Victorian-era engineering in motion. At the end of the run, the boiler is blown down, releasing heat and impurities in a final burst of steam. The cycle closes as it began, controlled, deliberate, and deeply rooted in railway tradition. In a striking display of Swedish railway heritage, Bergslagornas Järnvägssällskap operated a special steam journey between Munkedal and Lysekil behind the powerful steam locomotive B. As steam pressure built within its large boiler, the classic B-class locomotive came to life, driving its pistons and connecting rods with rhythmic precision. Thick plumes of steam and coal smoke marked its progress through forests, curves, and coastal scenery, recreating the atmosphere of mid-20th century rail travel. Designed for both freight and passenger service, V demonstrated strong tractive effort and smooth running, handling the line with confidence. The run offered passengers an authentic sensory experience, where sound, motion, and mechanical elegance combined to celebrate the enduring legacy of Scandinavian steam locomotives. Raw Mechanical Force tells the story of industry's turning point. This living collection traces the evolution of internal combustion engines from 1867 through the 1930s, revealing how these machines reshaped factories, farms, and entire economies. Here, the moment when steam gave way to gas, and gas later yielded to electric motors, comes vividly to life through sound, motion, and scale. Spread across more than 20 historic buildings and expansive outdoor exhibits, the museum showcases an extraordinary range of ignition systems, timing methods, and power transmission solutions. Each engine demonstrates a different answer to the same question engineers once faced: how to capture controlled explosions and turn them into reliable work. Nearly 300 engines form the heart of the collection, ranging from delicate units producing fractions of a single horsepower to massive machines capable of delivering up to 600 horsepower. Remarkably, more than half of these rare engines remain operational, not frozen behind barriers, but running as they were intended to run. It is a working archive of mechanical ingenuity that powered the Industrial Revolution forward. Starting the Antonov AM2 after nearly a month of inactivity is a deliberate, methodical process. The massive radial engine demands patience as oil circulates, cylinders clear, and ignition comes alive. Each coffin turn reflects classic aviation engineering, built for reliability, endurance, and operation in the harshest environments. Steel, iron, and motion take center stage at the Cool Spring Power Museum, where historic machinery is not displayed in silence, but run as it was meant to be. During the 2012 Summer Expo, massive early internal combustion engines come alive, revealing the raw mechanical power that once drove American industry. The focus begins with the 1913 Miller Improved Gas Engine, a rare four-cylinder 300-horsepower H-pattern machine engineered to drive an Ingersoll Rand Imperial air compressor. Built for continuous industrial duty, its synchronized pistons and heavy rotating mass demonstrate the engineering solutions of the oilfield era. At the Windy City Lease, a 1916 Blaisdell engine compressor combination shows how compressed air systems replaced steam for pumping wells, emphasizing reliability and mechanical efficiency. Inside the Power Technology Building, the spotlight shifts to a towering 1925 Otto single-cylinder engine. With twin flywheels and 175 horsepower, it drives a Worthington triple-piston pump, showcasing large-scale torque delivery at low speed. Every machine on site runs with purpose, precision, and unmistakable mechanical authority. The world's oldest steam locomotive in regular industrial use at the time, the meter gauge 1873, built Sharp Stewart 040, shunting cane wagons on the dual gauge. This old veteran was something of a celebrity amongst Indian industrial locomotives and was one of 9 locos delivered by Sharp Stewart in 1873 to the meter gauge Tirhut State Railway. Steam hisses softly as the Sentinel steam wagon rolls into Topcliffe, pausing not for fuel but for water. This brief stop highlights the ritual of steam operation, boiler replenished, pressure restored, before the wagon continues its journey, carrying industrial heritage forward on heat and vapor.